Hello everyone, we are from Group 3 in Assignment 2 of ENG 3002. The topic of our group is heat equation. My name is Ho Zihui and my other group members are Balkis Nabiha, Teshini, Noor Atira, Balkis Patricia, and Anusha. Now I will start with introduction of heat equation. The heat equation is a fundamental partial differential equation, PDE, that models the distribution and flow of heat in a region over time. It is commonly used to describe how heat diffuses through solid materials such as metal rods, building walls, or the Earth's crust. The heat equation, a second-order linear partial differential equation, in mathematical form is delta U over delta T, which represents the rate of change of temperature with time, equals to alpha, which is the thermal diffusivity, which is a positive constant, and multiple with delta square U over delta X squared is the second partial derivative, which describing how the temperature varies in space. U with x and t is the temperature at position x and time t.
Now I will explain about the phenomenon. Heat transfer happens everywhere, from the sun warming a room to lamps, ovens, and kettles. These are all examples of how heat moves from hot object to a cooler surrounding. In cooking, the heat will flow from the stove into the pot or pan, and finally into the food. The metal will conduct heat quickly, while the thicker pans will heat up more slowly. This follows the thermal diffusion, which are heat moves from hot to cool areas until the temperature evens out.
Next, I'll be introducing about partial differential equation. A partial differential equation is an equation that involves partial derivative of a function with more than one independent variable. It describes how a multivariable function changes with respect to its variable. It is used to model physical phenomena such as heat conduction, sound, fluid flow, and quantum mechanics. The function involved usually represent a physical quantity like temperature, pressure, or displacement. Common types of a PDE is elliptic, parabolic, and hyperbolic. It requires initial or boundary condition to solve it. Lastly, it also can be done through analytical method, exact solution, or numerical methods, which is approximation.
So next we move on to the initial condition. So have you guys ever held a metal rod over a fire while cooking something like satay or marshmallow? So at first, the rod feels cool that because it hasn't yet absorbed any heat. So this moment, before the heat starts to flow, is what we call the initial condition in heat conduction. So in our example, the entire rod starts at room temperature about 25 degrees Celsius. So this is before any heat is applied. So what is conduction? Conduction is the process where heat flows through a solid object like our metal rod. So from the hot end, which is the part near the flame, to the cooler end, which is the part you are holding. It is like a temperature change reaction. So the heat travels through the material by making the fast moving particles at the hot and bump into the slower ones. So this is passing energy along the rod. So this is why after a while, even the part you are holding starts to feel hot. So let's move on to the boundary part.
Hi everyone, so I have a quick question for you all. So if there is a pot full of hot boiling water, do you think the handle will be hot too? You might say yes, but actually it's not. We all can touch it, and the best part is the handle will be still cool. So what is the reason behind of this? Because the handle is made of plastic, and plastic is an insulator, which it doesn't let the heat to pass through it. So in heat transfer, we call this as a boundary condition, more specifically a zero flux boundary. That means no heat goes in or out at that point. So the metal part gets hot, but the heat stops when it reaches the handle. So this shows a real life example of how insulation works, and it will protect your hand and shows how heat can be stopped at the boundary. So that's all from me. Thank you.
So for the conclusion, the heat flow pathway where heat moves from the stove to pan to food through conduction with direct contact transfer with using the governing principle, which is thermal diffusion. Heat will always flow from hotter to colder region until temperature equalizes. Mathematically, this is described by the heat equation as it's shown in the slide. And this PDE shows how temperature changes over time based on its spatial distribution. Thank you for watching.